My name is Jack Langelaan. I am an Associate Professor of Aerospace Engineering at Penn State's College of Engineering. Aerospace engineering layers the design, analysis, and operation of aircraft and space vehicles to allow for transportation, communication, and exploration far and wide. Aerospace engineering students complete coursework and fundamental engineering principles to lay the foundation for further studies in aeronautics, astronautics, and specific technical areas within these fields, including aerodynamics, structural mechanics, flight mechanics, propulsion, controls, software, and autonomy. The aerospace industry is a huge contributor to the national economy, with $928 billion in sales, 881,000 direct jobs, and 1.67 million jobs in the aerospace supply chain. You'll also find our graduates working in industries where our unique skills are used to develop products ranging from sports equipment to medical devices to automobiles. Penn State Aerospace Engineering alumni are well versed in the use of systems engineering approaches to problem solving. Many go on to graduate school, after which they work in industry, government, or academia. Penn State's Department of Aerospace Engineering is developing the technologies that will be used in next-generation wind turbines, airplanes, helicopters, rockets, and spacecraft. I think aerospace engineering has been really important in improving the lives of people everywhere. Aerospace engineers tend to work on a system as a whole. We're not just focused on one little component of a system. Aerospace engineers tend to focus on the aircraft or the spacecraft. So if you're interested in really big picture problems and in how the different fields of engineering like structures or controls or propulsion or aerodynamics or fluid dynamics all come together in one complicated system, then aerospace engineering is the field for you.
You know, it's one thing to sit here on Earth and to look up and think about the things that are above us that we can't see. It's another thing to actually be able to figure that out, solve for where these things are, determine where they're going. All of the work that goes into predictions and orbit determinations, we still have this area for improvement that leaves room for creativity, also extremely interesting.
I think my job is very, very exciting. I get to balance so many different things, and every day is different. One day I'll be applying my aerospace skills to work on a new design for a helicopter bearing. The next day I might be working on an oil and gas project where they need some CFD capability. So I love that ability to take ownership of my skills and be able to excite others and solve real problems with them.
Aerospace engineering in the modern age has to incorporate so many different things beyond just structural engineering or aerodynamics. We're able to get this flavor of all the different engineering aspects, from mechanical engineering to computer science to electrical engineering to even physics.
Aerospace sort of takes all of those different majors and disciplines and throws wings on it or puts it underwater and forces it to move. So the one thing I'd say I love most about being an aerospace engineer is the fact that it's taught me so many different ways to solve problems.
Well, it's actually a very exciting time in aerospace. The ways that we're kind of looking at taking this new technology that we have with electrically driven propulsion systems and integrate them into vehicles in novel ways that people haven't thought of. And it's really exciting because now we can make aircraft more efficient, we can make them much more environmentally responsible, and actually even cheaper to operate.
Across all disciplines, part of our department does material science research. We're talking about smart materials, additive manufacturing, where you can 3D print not only vehicles, but some researchers are exploring fuel sources being 3D printed and things that are going to help society as a whole adapt to the changing environment.
One of the biggest things that I think that makes aerospace engineering unique is that as you progress through the years, you get to get a really unique experience in that the class size is really small. For me, I was able to kind of build those connections and have that more smaller school experience here in such a large university.
I really want to be able to have an impact on the way we design our aircraft and make sure that the next generation of aircraft for commercial use are safer, more efficient, and better performing.
I hope to one day be able to see what I work on, fly out into space.
We are now going through essentially the second space race. I really, really hope to get the opportunity to work directly on projects that are helping the next generation of humans to go to Mars.
We have gone from that first flight to landing on the moon, to landing spacecraft on Mars, to be able to fly at supersonic speeds. There's still a lot of challenges in front of us. We have to make sure that air transportation continues to improve in its environmental impact, and we have lots and lots of exploration to do in the solar system. So there's still a lot of exciting things for us to do in aerospace.